Welcome all. In this video, we are going to discuss about process and its concepts. What is meant by process? A process can be thought of as a program in execution. What is meant by process? Process is nothing but it is a program in execution. So we can call the process as an active entity instead of calling it as a passive entity. So program in execution we call as the definition for process. A process needs certain resources. So these are the resources the process requires. CPU time, memory, files and IO devices in order to accomplish its task. So these are the resources can be allocated to the process during the creation or during the execution of the process. The current status of the process is represented by the value of the program counter and the contents available in the processor's registers. So this is the diagram which shows you how does a process looks into a memory, or simply you can call this is a memory layout of a process. The memory layout of a process has been divided into multiple sections. The various sections are text section. What is meant by text section? Here text section you can see at the end, at the bottom. So what is meant by text section? So text section is nothing but the section which contains the executable part of the code. We can call that as the text section. And the next one, the one which is just above the text section is data section. In this data section, the process holds all the global variables. The global variables which are used by the process are available in the data section. So the next you can see a heap, or you can call this as the heap section, and this is the memory that is dynamically allocated during program runtime. So it depends on the size of the program. The memory can be allocated to it dynamically. The next one you can see is a stack. So stack, it's a temporary data storage when invoking functions, such as the stack can hold the function parameters, the parameters which are passed between the functions, the return address and the local variables. So these are the data that are available in the stack. So this is the memory layout of a process. So during the program execution, a process can be available in the memory in this structure. The next one we are going to see is process states. The next one we are going to see as process states. So when a process executes, process can move from one state to another state. A process can be in any one of the following states. So there are various states associated with the process. They are new, running, waiting, ready and terminated. So these are the various states. So as process executes, it changes states. Your process can be in new state, or your process can be in running state, or your process can be in any one of the following states. So in this diagram also you can see the process new. It can be in new state, ready state, waiting state, running or terminated state. So process can be in any one of the following states. First, we'll see what is meant by new. So what is meant by new? New is nothing but the process is being created. It's something like a newborn baby. The process is just created. So that only we call it as new state. Next one is running. So what is meant by running? The instructions, the set of instructions available in a process are being executed by the CPU. We can call that as the state of running. We can call that as the state of running. The next state we have is waiting state. A running process can be moved to a state called waiting. In case if a process wants to perform any of the IO activity in the sense, suppose your process wants to open a file. In that case, the IO device does the operation on behalf of the process. So the process can be moved from the running state to the waiting state, where it waits for the access of the IO devices. I hope you understand. The next we have is ready. So what is meant by ready? So ready in the sense, after the completion of an IO operation, the process is now ready to execute. But it cannot be directly moving from waiting state to the running state. So it has to kept waiting in a ready queue until the CPU is available to execute the process. So the process, all the processes want to get the access of the CPU has to be kept ready in a, has to be kept waiting in a ready queue. One by one, the CPU picks the process from the ready queue and executes it. So when the CPU is free, now the process which are in a ready queue will be taken by the CPU and it starts executing it. And next we have something called once the CPU finishes its entire set of instruction, it can go to a state called terminated. Now the process is completed execution. So here you can see another operation called running to ready. So these arrow marks shows you what kind of operation is happening when a process moves from one state to another state. And you can see a state. Here you can see a state. So process moving from running to ready state. So what is this? So why it is not coming to waiting state? It is moving from running to the ready state. In case if your process, a running process gets an interrupt, in that case your process will move from running to the ready state. The interrupted process will be executed by the CPU. Until that time, your process will be kept waiting in the ready queue. So once the CPU is available, it picks the job and it will continue its execution from where it has been left off already. So once all the line of code available in the process is executed, now the process is called as terminated. The process has finished its execution. So this is the process states. So this is the diagram which shows you the various states of process. So what are the various states we have? New, we have running, we have waiting, and we have ready state, and we have terminated state. So here we have, there is a transition happening here. A running process can move from running stage to a waiting state. A waiting process, after the completion of the IO operation, from the waiting state, it will move to a state of ready state. If the CPU is available from the ready queue, a CPU picks the job and it starts its execution. This is a kind of transition happening. And you can see one more transition. A running process is moving from running to ready state. So this is happening on cause of an interrupt. So these are the various states of a process. The next we are going to see about process control block. Each and every process is represented in the operating system by a process control block. So each and every process will have something called process control block. Every process is associated with a process control block. We can also call this process control block as task control block. It contains so many information. So one of those is process states. What state your process is, whether your process is in a state of new or it is in a state of ready, running, waiting, halted. What state your process is now. So those information will be kept in a process control block. The next information is program counter. So as you all know, what is meant by program counter? The program counter indicates the address of the next instruction to be executed for this process. So that information will be available in a program counter. And also it contains CPU registers. So the registers are vary in number and type. It depends upon the architecture of the computer. There are so many registers available in the system. Some of them are accumulators, index registers, stack pointers, and general purpose registers. The next information the PCB holds is CPU scheduling information. So what is CPU scheduling information? So it holds what is the priority of a process and pointed to the scheduling queues and other scheduling related parameters. The next one the PCB holds is memory management information. This information may include such items as the value of the base and limit registers, and the page tables, segment tables, depending on the memory system used by the operating system. So memory management information, it holds what is the base register value and what is the limit register value. If it is if your system supports paging, it contains information of the page table, or if your system supports segmentation, then it contains information with respect to the segment table. So this is what we call it process control block. So other than those information, it also got something like accounting information. So what is meant by accounting information? So amount of CPU and real time used by the process. So how long it has been executed. So what is the process number? So those kind of accounting information also the PCB holds. So next one is IO status information. What is IO status information? It includes a list of IO devices allocated to the process, list of open files, all those things. Also the process control block holds. So we can simply call the PCB simply serves as the repository for all the data needed to start, restart a process along with some accounting information. So this is the structure of the process control block. So here you can see process state. So state can be anyone. It can be in a state of running. It can be in a state of ready, whatever it is. Next, process number. Each and every process is identified by a process number. It is a unique integer which identifies every process. Next one is program counter. So the program counter holds the address of the next instruction to be executed by the processor. Next, it contains the registers and the memory limits. So memory limits in the sense which byte of instruction in the memory the process should access. So that is memory limit. So this value is held up with the base and the limit register. A list of open files. So what are all the files have been allocated to a process? So those information also the PCB holds.